Today we're going to learn how to write electron configurations. Electron configurations are the address of all the electrons in an atom. So it tells us where all electrons in an atom live. And so today we're going to organize ourselves by coloring our periodic table. And we're going to do that in just a moment. But Schrodinger's model is our current model. It's also known as the wave model. It is based on the fact that we believe that electrons have wave and particle properties. So when they move not only as particles, but also in the same fashion as a wave does, like through the valleys and troughs and such. Alright, and it's a much more accurate model so far than was Bohr's model. It helps us to know where all of the electrons are located. Okay, and we get this information from the periodic table. So if we recall, the periods are our rows, and they represent the energy level. Now that's the same as the Bohr model. Okay, and then we're going to color in the sections that are going to represent the sublevels. And so what happens is Schrodinger's model takes energy levels and breaks them up into sublevels, and then also further into orbitals. Okay, and so let's look at a periodic table and see where these different sections are located. Alright, so on our periodic table, you see we have there are different sections in the periodic table. The first two columns represent what's known as our S sublevels. Okay? And we're going to color those in. I picked red. So we color in our S. Now, for the purpose of electron configuration, helium is imagined to sit here next to hydrogen. So it also is part of the S sublevel. The reason that it's over here to the far right is because it's a noble gas. Okay. Next, we have our P sublevel. I'm going to color that one blue. Our P sublevel are the 6 columns to the right.
The following teachers, please return your verification sheets to Ms. Berry. Ms. Castillo, Ms. Evans, Ms. Lowry, Ms. Brenda Taylor. Please return your verification sheets to Ms. Berry.
Alright. And then we have our D sublevel. I'm going to do those green. And they're the 10 columns here in the middle. These are the ones that has our common metals like iron, copper, zinc, silver, gold, mercury. It also has some elements that we're not very familiar with, like tungsten. Although tungsten used to be that you would have experienced tungsten most every day, you turned on light bulbs. They're in the incandescent light bulbs. That's the filament in the incandescent light bulb. Although not many of us have too many incandescent light bulbs anymore. Alright, and then finally we have our F sublevel. We'll color those brown. And there are the 14 columns down here at the bottom. You, of course, could choose any color you like. These are just the colors I chose today. But having them color-coded is going to help us to remember where one sublevel ends and the next one begins. Alright, so there's our periodic table, and we've colored it in. And remember, our energy levels are represented by our periods. So we're going to number them 1 through 7 here. Now, based on Schrodinger's atomic theory, the periods would go on infinitely.
May I have your attention, please? All teachers, it appears that all scores are in, including constructed response and English 2. They will be in your mailboxes momentarily. Again, all scores are in. I am printing them now, and they will be in your mailbox momentarily.
Okay. So let's talk a little bit about, so the sublevel, we have energy levels and broken down into sublevels, and then the sublevels are broken down into orbitals. Okay? So the S sublevel has orbitals that are shaped like spheres. Okay? That's where the S comes from, a sphere. Its maximum number of electrons it can hold is 2, and it has the least amount of energy of all the sublevels. P, they sort of look like dumbbells, or maybe even infinity size. They kind of look like that. They can hold up to 6 electrons, and they have slightly more energy than the S, so greater than the S sublevel. If you look up the periodic table again, so the S has 2 electrons, and there's 2 columns, 1, 2. P has 6, and there are 6, 2, 3, 4, 5, 6. D has 10, and there are 10 electrons there, and F has 14.
Teachers, may I have your attention, please? With scores being back, all grades will be due to Miss Berry at 12.
Alright, and then D sublevels have, or D orbitals have a shape which is like a double dumbbell, so it's got it sort of like that. And again, they have 10 electrons, and they have more energy than both S and P. And then F is very complicated. That's good enough for now. And the shape, very complex. And then it holds up to 14 electrons, and again, that's because there are, on the periodic table, 14 columns in this section if you count them. Okay? And they have the most energy. Okay? Now, the D sublevels have so much more energy than the S and the P that we fill them up later than we would expect. So, for example, this first row of D is actually the 3D, the second row is 4D, 5D, and 6D. So you see here we would have a 4S getting filled in before the 3D does, and then after that would be our 4P again. Likewise, 5S, 4D, 5P. And then F's, like the D's, have so much more energy that they actually fill 2 periods later. So the first row, which fits right here, and that 6th period is actually the 4th energy level, and the second one, which fits in right here, is actually the 5th. So again, these two fit in right there. Okay. So, let's see how electron configuration works. We're going to start with the simplest element of all. Simplest element of all, of course, is hydrogen, because it has just the 1 electron. So hydrogen has the 1 electron. It's in the first energy level, so that'll be a 1. And then the sublevel is S. And then since it's the first element in that sublevel, we have a 1 to represent the electron. So the electron configuration for hydrogen's 1 electron is 1s1. Next we would have helium. Helium, still in the first energy level, still the S sublevel, except that helium has 2 electrons in that sublevel. Now the S is maxed out, right? The 1s is maxed out. So now when we go down here to the lithium, which has 3 electrons, right? 2 of them, the first 2 live in that first energy level, just like helium, 1s2, but then the third one is in the second energy level, so it's going to be 2s, and it's at first position 1. Alright, beryllium, right next to lithium, has 4, and it would have those 2 in the first energy level, and then it'd be 2s, and since it's the second one, it'd be 2s2. Okay. Next, we'll skip to nitrogen. Nitrogen's over here. Right, so again, we're going to start, keep all this on the screen for you. We're going to start back always at the beginning. So we have 1s2, then we have 2s2, and then we have still 2, but now this is P, and nitrogen's the third one. 1, 2, 3. So that's going to be 2p3. And nitrogen has 7 electrons, so if we count our electrons, 2, 4, and 3 make 7. Alright, next, let's do neon. Alright, neon's over here. So again, we start at the beginning, 1s2, then we have 2s2, then we have 2p, and neon is the 6th one, so it'll be 2p6. And again, if you count your superscripts, they'll equal to 10. Okay, let's skip it down. Let's do phosphorus. Right. Starting from the beginning, 1s2, then 2s2, 2p6, 3s2, and then 3p, and phosphorus is the third one. So that's where we would stop, 3p3. Alright, well, let's see how these D's work. Let's do chromium, Cr. It's all the way down here. Alright, so we have 1s2, always from the beginning, 2s2, 2p6, 3s2 right here, 3p6, 4s2. Now here's where it changes up. Remember, this is 3, D, and it's 1, 2, 3, 4. That's the fourth one in the 3D. Alright, let's do bromine, Br, all the way over here. Alright, so we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, and there's 10 of those, remember, and then back to 4, p, 1, 2, 3, 4, 5, and it's the 5th one. If you want to write in over here, 2, 3, 4, 5, 6 to help you remember to go back to your original energy level number, you can certainly do that. Alright, as you can see, these will continue to get much longer. I'm going to leave you with a couple to do for class tomorrow, just so you can practice on your own. So go ahead, let's see. Oh, I don't want you to do that one. Let's do, zirconium and gallium and we'll do sulfur.